Hey folks, today I had a great opportunity to talk to Andy Lee over at Cnc Labs. You know, he's just the CEO and all. He showed us around the shop, talked a lot about where the company has been and where it's going, and showed us something I like to call the arc. Today also I'd like you to please, if you have a second, like, comment, and subscribe on this video, which helps me out a lot and really helps us put these videos together for you in the future. So please join me today on McLaughlin Woodcraft. Hi everyone, and welcome back to another exciting edition of Noobs for Noobs. I'm here with Andy Lee from Sienci Labs. Welcome,
Hello.
Andy. Welcome to the channel. And hopefully this one's going to be better than the last one in that I'm actually recording who I'm talking to. So hopefully everyone here will get to see you, Andy. Appreciate you coming. Welcome. And I'm going to start right at the beginning, Andy, of what's the story, man? You guys are in Ontario. And suddenly, you know, you guys are playing around, and next thing you know, you're running a company that we all know and love. So let's start at the beginning, man, and tell everybody about yourself.
Sure. Yeah. So I'm Andy. I'm the CEO of Cnc Labs. I'm one of the co-founders. I work with Chris. He's over there. You probably watched the other interview where Chris got to tell his part of the journey. But I guess this time it's my turn, right?
That's right.
Yeah. So yeah, I guess where do I start? So me and Chris we started the company in 2016, January 2016. Before that, before I went into university at University of Waterloo, I had always been interested in CNC machines. I actually made like boats, like small like lake boats, like for paddling and stuff in my garage. I would have like a jigsaw and make like templates with paper. I would cut them out of like plywood and things like that and then glue them together. That was like just like something I did as a kid. But while I was doing that process, I learned about CNC machines, and I thought they were really cool because you could cut the shape of the template or like the ribs or like any part of the boat with a CNC machine. So people could like model them, use like finite element analysis and make a shape that would be perfect for whatever application you're using it for, right? And so I was like, yeah, that's really cool. But CNC machines, like, not only are CNC machines really expensive now, they're like especially expensive back like, I don't know, it's been like 10 years or something. So yeah, they were like super expensive. So I never had the opportunity to use the technology. I just got to read it. So yeah, that was like something I was always interested in. That's part of the reason I went into mechanical engineering, because I wanted to learn about the technology. I eventually started my first co-op job once I got into university. I did mechanical engineering, or at least I did 2 years of mechanical engineering. My first co-op job as an engineer was to work at this, like, how do you say, conveyor material handling like company. They made conveyors and chains and other heavy duty parts for these like systems that move material in lumber, mining, power generation, things like that. And one of the jobs that I had was to program their CNC torch cutter. So we'd be cutting like 3-4 inch thick sheets of steel for making sprockets and things like that. And when I started that job, I was like, I told my boss, I was like, hey, I really want to learn this. I think I could like figure out how it works. Would you be willing for me to learn this on my own spare time? And would you be willing to like give me the job if I could do that? He was like, yeah, no problem. So, you know, I spent a couple of weeks learning the process, the programming, how it all worked. And I thought it it's like the coolest thing. Like you get to see a machine do the work, cut out parts perfectly. You don't have to worry about how good you are with your hands. And I was hooked at that point. I eventually left that job and I went back to school. And then my second co-op job was at a startup. My job was to design these robots that hand wrote letters. So the idea was if you were if you want to market something, for example, like a lot of politicians use this service. They would get you to handwrite letters to say, hey, can you like vote for the Conservative Party or whatever. But you would want to send those letters out to thousands and thousands of people. So instead of getting people to handwrite them themselves, you use the machine. Mm-hmm. And in this case, we used the Shapeoko 2. Yeah, that was like my first ever kind of like touch point with hobbyist CNCing, because the startup basically attached a pen to a Shapeoko 2, and then they had like a conveyor belt. So you put the paper on the conveyor belt, it would come down, and you'd write its thing, you would move around and all that sort of stuff, and it would spit it out the other end. During that time, I think to build one like Shapeoko 2, it was like $2,000 to $3,000. And for me, I was like, hey, I'm an engineer. Like I've worked with this sort of stuff before. I had to build these machines and work with all these little components. And I thought, I feel like I could probably build my own CNC machine, but my goal would be to make it accessible for hobbyists. And during this time, this is when 3D printing started to take off. I don't know if you're familiar with like the RepRap project, but that was when people started to build their Mendel, I think they're called Mendels, mm-hmm. and with like the threaded rod and everything. Mm-hmm. So that was taking off. The whole like open source and like RepRap movement was chugging along, but there wasn't really anyone. There's not a lot of players in the CNC field. And I think Chris mentioned that in his interview as well. There's not a lot of people doing CNC, but we're using. Both me and Chris used a lot of 3D printing, so we thought, okay, let's try making a CNC machine. Mm-hmm. So I worked at that company. I built. By the time I left that company, I had designed and built like basically a new robot to replace the Shapeoko 2 system. And using that knowledge, going back into school, I made it like a personal project to build my own CNC machine. And during that time also, because I was working at this startup, I had a really good and interesting experience learning about kind of the ins and outs of being in a startup, like the business side of things like that. So I thought, hey, that's really cool too. So my elective was in a class called Bet 300. It's like it's business, entrepreneurship, and technology course, selective. So to do that course, you have to come up with a business idea. And my business idea was essentially, I want to be making linear motion for CNC machines and 3D printers and things like that. So that was kind of how it got into my head that maybe it's also viable as a business. So at the very beginning, we were working on making different linear motion systems. And if I could probably walk to the other side of the shop and show you what like the first prototype. I can't believe we hold on to this for so long, but
you've actually read my mind. That's where I was going next with this. Like, yeah. Oh, hey, you're standing right there.
Yeah. Yeah. So hold on, let me see if I can flip my camera around.
You bet.
Yeah, there it is. Yeah, so there's a thing. There's a blast of the past. So yeah, how do I flip this around? Oh, there it is. Yeah, so basically, this was like one of the first prototypes, maybe like the second or third prototype. But the idea was to mill the chamfer on a flat bar like this, and then we were using V rollers and some bolts to kind of like compress it into the groove. And then on the other side, there's a belt system here. So it'd be attached to a motor, which is there. And that could like run the machine back and forth, essentially.
It's like the Ark, man. It's the first, you know?
Yeah. Yeah. Looking back, this is like not a good design. But this was where we started. Like we built a machine like with all these components. These are like OG, like Chris printed these guys. Like you can see how rough the quality used to be with like old school 3D printers. But yeah, that was how we did it. And we posted this on some forums, like some ideas, and we got like absolutely wrecked. Like people were like, this is like the worst design I've ever seen, right? And I guess like in hindsight, you're right. One thing that we learned is about building machines is that not only does it matter like on a physical like technical standpoint that is rigid, but it also has to look rigid. Like when we did the FEA analysis on this design, because it's made of cold rolled steel, it is pretty strong overall, but it looks like it's just a bar of steel. It doesn't look very rigid. So yeah, we got wrecked on that. But that was a really important learning step in terms of building machines. So yeah, over time we eventually came up with different designs, and eventually we started building the Mill 1, which is down here actually. We have a demo unit. But we use these are you probably remember seeing these on the long mill. This would be on the y-axis, but essentially we use these on all 3 axes. You can kind of see it. So it would move back and forth. This would move back and forth. And that was our first foray into building a machine. So when I was doing this class, we started off by making that prototype. And we thought, hey, like maybe we could like sell it to other companies to use, or like maybe we could like work with other companies to design machines. But then we realized it probably made more sense for us to use the design ourselves. So we came up with that angle aluminum design and implemented into what became the Mill 1. During this time, I was still also in that class. So we were also like going out to like sell the machine. Like we had like it was like a startup, right? It was a startup class. So we were a startup now. We had this machine and people were actually interested in buying it. Like we're at a university where there's a lot of engineers. So there's a lot of interest in that. And also we were part of the maker community. So we would go to maker events and people were interested in as well. So I guess at that point it got into our head like, oh, maybe we should sell it. So because me and Chris at that point we were in second year university, I think first year. I think we're in second year university. So we're broke as like we're really broke. I think when I started that term, I had like $800 in my bank account.
And you still had to eat.
And I still had to eat. So
where'd you meet Chris? Andy, sorry to cut you off there, but where'd you guys meet?
Yeah, so me and Chris were actually in the same engineering program. We're in the same class. So we just met. We met through like school, and then we started hanging out. We used to make like hash brown sandwiches. Other throwback to being a broke university student. We used to fry hash browns. I think you can buy like a pack of 12 for like $3. And then you put ham between, and then you put ketchup, and then you made a sandwich.
Sounds fantastic.
Yeah, we'd go to his like dorm room, and we would make these sandwiches, and then he would teach us how to break dance. That was like something that Chris did.
We did something very similar, except we weren't anywhere near as classy as you guys. We did a big silver bowl full of Mr. Noodles, and like 5 of us would just eat out of one bowl.
Oh yeah,
do what you got to do.
Exactly. Yeah, so we that's how we met. Obviously we had like a lot of similar interests in terms of engineering, machine design, and things like that. And we, like, us being in the same class and everything, we eventually, me and a couple of other guys from university, we rented a house together, like a student house together. So that's kind of how this whole story of how, like, we ended up taking over, like, we had a 3D printing farm in our laundry room,
Yeah.
and we built machines out of a garage type of thing,
Mm-hmm.
because it was 5 guys in a house. We took over the garage. We put all of our machine stuff there. I was working on machine stuff in my room. We had like a shoe closet kind of thing. We had like testing as well, and then we had 3D printers in the laundry room. But yeah, so we basically moved in together before we started Cnc Labs, into a student house, and then I also stole a lot of his tools. Yeah, Chris had like this toolbox where he got, like, he had everything, like drills, screwdrivers, pliers, everything. And so I just kind of like stole all of his stuff. And I also like artist 3D printer as well, and I would like help get him to print. So yeah, when I first went into that class and had that idea to start working on CNC related stuff, when I was building the prototypes, I was using Chris's stuff, and eventually Chris was like, yeah, I'm like so involved in this project now, like maybe we'll just like make this a company together. Mm-hmm. So that's how we kind of ended up becoming co-founders. Yeah, just me mooching off his stuff. It was like, I guess I got it.
Well,
yeah, I guess like an early way to get started, but yeah, so
it's amazing when you review that.
I was in this story.
Well, but it's amazing when you review it and you look back, because I'm sure there were a lot of sleepless nights. And Chris touched a lot on the Kickstarter, which is I discovered Cnc Labs when the Mill 1 was released.
Oh, wow!
And I was looking, and when I say I mean my wife and I. We were looking for something that we came, same as you. We came from the 3D printing background. Like I always have that on display, my full-scale proton pack that's back there over my shoulder. That was something that I built. And we were looking at a bunch of different products, but most of them were like Amazon-based, very simple, small little mills. And X-Carve was obviously something that we were looking at, because that was kind of the one at the time that was on the scale that we were looking at. And then we discovered Cnc Labs, and we're from Ontario as well originally. It was just a good fit for us, and we never looked back. But as a couple that have started a company from the ground up, I want to ask you a little bit about, because the theme of this program is for that new client, that new person coming along that is looking for a product like yourself, that you guys have created. Let's talk a little bit about, okay, so I want to start my own company, and I want to buy a long mill, and I want to buy your long mill. Mm-hmm. But to start with, I look at things with your company like we did over here. Sorry, I'm all backwards here, but the logo. Let's start with the logo. The Cnc Labs logo. So you guys are sitting around, because Chris touched on it a bit. You got to figure out how to do a website. You got to figure out how to make something that the everyman can purchase and afford, and it has to be scalable, and it has to be open source, and all these checkbox that you really are designing for guys and gals out there that really, like us, are working out of our garage. And so you start this company, you and Chris, you're mooching tools off them. You're trying to scramble to get this Kickstarter obligation behind you guys, because like Chris touched on, and I'm sure you can attest to, the response was very good. And so you got this company. Well, hey, why did you call it Cnc Labs? Let's start with that, and let's talk about the logo and things like that.
Right. Okay. So yeah. So starting with the logo, it doesn't have like any exact meaning. There's kind of a couple of elements. So if you're not familiar, there's like the circle, and then it has a triangle in the middle that's supposed to represent a play button, like to start something. And then the other like lines that make it up kind of end up looking like an end mill, the tip of the end mill. So yeah, that's sort of like the idea, the concept behind it. Because we're engineers, of course, we use SolidWorks to design this. It was just like lines and extrusion, so it was just like geometrically very simple. So yeah, I remember modeling it where it's like, oh, this is a cool design. So we stuck with that, and I guess over all these years we kept sticking with that. In terms of Cnc Labs as a name, Cnc obviously is a word or play on like the acronym Cnc. The reason we kind of like made it into a word is because we kind of personify machines. When something doesn't work on a machine, we treat it like it's a person. People get sick. People like have weird habits. So we have like personalities for the machines that we use. So CNC was kind of the idea kind of behind that was, it could be someone's name. CNC is like a person's name, and we want to attribute that kind of idea towards what our machines are going to be like too. And then labs is, we use that because it connotates the idea that we're always creating stuff, developing stuff, and learning stuff. So it's to show we have, how do I say, like a tinkering type of side to what we're doing.
It's basically always innovating, I think, would probably be a best way of summarizing, I think.
Yeah. And I think a big element of the way we do things, we're always interested in kind of like guerrilla engineering, using stuff that isn't really designed to be used in the way that we want to use them. The angle aluminum is a perfect example. That's just like standard structural aluminum, but we use it as a linear motion system. But we have other things that we kind of use in different ways, try different things that other people haven't done to implement in our designs. So yeah, so the labs part is kind of to touch on that kind of idea. I think in hindsight, Cnc Labs has been a bit difficult to pronounce, and people have mistaken like the pronunciation of it a lot. So in a way, in hindsight, I guess I should have we should have probably picked a name that wasn't so nebulous. But it is what it is now. Like, we're way in too deep. Actually, when we named the long mill, we were like, okay, we should pick a name that is easy to say, easy to spell, can't be misspelled, and can act as like a name for the product, but also like the concept or like the company itself. So when someone says, oh, get the long mill, they don't have to say, oh, get the CNC long mill. They know what long mill is just by saying that word, if that makes sense.
Yeah.
So
yeah. Kind of like saying a frisbee, like it's the long mill. Well, you talked a little bit about innovation and new ideas, and Chris touched on it in our last interview as well. So you guys get past the Kickstarter. Wow. I mean, and then you decided to look at the long mill, and the response was fantastic. And then you decided to come up, because you've gone beyond just a long mill in that now you've started to look at external components to add to it, whether it was something like the touch plate or the dust shoe. And there's been versions even like just of these individual, and the laser being the newest thing coming down the pipeline. But I always like looking at the dust shoe, because that was something that I was like, should I get it? Should I not get it? You watch videos, and some people have it, some people don't, and stuff like that. By the way, get it. If you're thinking about get it, don't even hesitate, get one. But the you look at the versions of how even the evolution of the dust shoe has come.
Hmm.
How receptive is the Cnc Labs staff to input from the community? I already know the answer, but being that it's open source, how receptive are you guys to people's with their suggestions? Like, well, maybe version 1 of the dust shoe has now been replaced with a different version of the dust shoe, and there's been a lot of tweaks and stuff. But just in general, we can talk about that kind of concept.
Right. So yeah, so that's the way that we kind of handle the way that we handle like what the customers say and how we work internally is actually really fascinating, in my opinion. The people that we like, the people that you interact with, like between a customer and us, the distance between them and their involvement in that part of the company inside internally is one person away, essentially. So what I mean by that is, so for example, we have Kelly, who some of you guys might have met or heard, like talked to. She does most of our technical support. She also does a lot of our engineering, and she does a lot of our quality control, and she also adjusts a lot of our designs internally for whatever people like comment, right? So here's one example. So the other day we had some problems with the nut fitting in the dust shoe. Some people are commenting that they had to like file down part of it because it wasn't fitting. And Ron, who's working behind me, but in the printer farm, he had adjusted the print settings recently to improve the strength of the part, but inadvertently caused the nut size to change. So because Kelly is like, because Chris designed the dust shoe, Kelly sits right next to him. She also is involved in the QA. Someone like, she found out that there was a problem, got Ron involved, got Chris involved, all of us, and also got Chase involved, who's part of the assembly process, to like find stop the production for that, find the problem, adjust it, make it better, fix it, so that all the other dust shoes that go out have like been fixed as soon as that problem arises. Another example would be like, let me just think. There's like longer term changes that we've made. I think one thing was that with the dust shoe as well, people were having problems with like moving the Z-axis up, the original design up and down, because you had like two extrusions that it had to go up and down on. And because we're part of the forum, we're part of the all the groups, and we'll also get like feedback from our customers. Chris basically was like, we can't use this design anymore. It's not good enough. So it was a goal for us to like come up with a brand new way to make the dust shoe, right? So the people who are giving, so it took a few months to do, but we got to that point. But in that whole process, the distance between the person who's giving us the feedback and the person who's actually acting on making that change, there's no gap at all. You're talking directly to the person that actually is involved in that process. So I think that's just like a really cool part. I guess another thing, like even on the customer service side, Patrick does all of our shipping and fulfillment. So if you call the phone, he's always next to the phone. So if you say, hey, I'm Bob, I bought this machine a week ago, I just wanted to I have a question about it. Like Patrick will know who you are. He'll know like what he shipped, when he shipped it, and he'll be like, you'll get a direct answer from the person who actually went through the process of making sure that machine gets out the door, right? So there's no room between. You're talking directly to the person who's involved in that process, and if there's a problem, it's in their best interest to like find a way to make things better. So I think that's just like a interesting way things have come to be. Mm-hmm. So yeah.
Well, thank you very much for that insight. That's important. I know it's important for us. And it's kind of another reason why we like to be involved in this company, at least from a small business perspective that we've been dealing with you with. Also, things that I've noticed you guys have been doing is looking at everything from bits to the laser. The laser, I guess, would probably be one of the bigger projects you guys have going forward. So let's talk about the, so how does it work for you guys? Like, how far ahead are you finding yourselves having to plan out? Like, I guess the laser would probably be the best way to look at that. Is so I know, for example, once we get set up in Newfoundland, the very first thing we're going to be purchasing is we're going to be looking at is the laser, because it just opens up so many doors for us from a company perspective. Projects like you see over my shoulder, sorry, over here, that that's a graphic on the badge, but it would look so much better as a laser. So let's talk about that. So you guys have decided, say on a some Monday, let's look at doing a laser. How does that all happen? How does that come together to get to where you are now?
Well, I guess that it's a complicated process, of course. One thing that's changed over the years is that at the very beginning, there's a lot of risk to decide what to produce and how many to make. And then but the speed of which we can make those things is a lot faster. So like, for example, when we first designed the long mill, we just made them all by hand. We sold like the first 10 over the course of like, I think a month or two. And because we just like made them all by hand, it was a really fast and easy process for us to like get to that point. The laser, on the other hand, now we have thousands of customers, and the laser, we need to design and make the laser in a way that we can serve thousands of customers, but not only that, make sure it's reliable and safe for all those people too. So now the risk of actually making the laser is lower because we know we have enough customers to support that feature, but it takes way longer because we have so much extra work to do. So I guess that's like one thing to note, just the way that kind of how things changed. But in terms of how the laser came to be, so we always got a lot of feedback saying, hey, I would really love to have a laser on my machine. And part of the answer was when I created the guide to putting an aftermarket laser on the machine. But we kept on seeing problems where people didn't know how to wire things. People didn't know which laser to pick. There's a lot of extra steps that people didn't understand or know. So Akena is our operations manager. He also talks to a lot of customers, and a lot of customers have told him, hey, I have problems with using a laser on your machine. So yeah, I guess it got into his head, like, I want to make this as a project. I want to make laser possible. And Akena, he used to actually have a company making electric bikes. So he's no stranger to creating projects and manufacturing things. And he had a lot of experience working with lasers from his previous job. He used to run a makerspace. Mm-hmm. So it all kind of like basically kind of was like, hey, Andy, like operations is cool, but I want to like take it one step further. I'm going to design a laser. So I was like, go for it. Like, let's make it happen. So yeah, it was just a project that he started with, and then it eventually became a project and a product. So yeah, I don't think like most of the stuff that we do doesn't start with that. Most of the time we get enough feedback from customers saying that they want something, that then we can go out and design those things and make those things. The T-Track would have been a good example. That was a project that Kelly did. We just saw a lot of customers that were buying T-Track, but they didn't know which ones to get, and a lot of them had their own flaws. So we just designed our own version that works perfectly in a CNC application. So yeah, I guess the long story short, we just get a lot of people telling us that they want something until the point where someone decides to make it, and that's how it comes to be.
Well, it kind of goes along with the evolution of your company, right? It's just one step So where are we going? What's the next 365 days looking like at CNC Labs? I mean, you were printing out of a laundry room, then you moved to a space, and then had to go to the space you're in now. Like, you guys have all fought through COVID like the rest of us. What's the next 365 days looking like in CNC Labs?
So I guess there's a couple of things. One is like developing new things. Laser is one of them, and then we have a couple other projects that we're working on. Chris has been actively working on G-Sender, and he also has some other software projects that the developers are working on. We're also working on some new electronics as well. So there's a whole host of projects that we're working on that's going to add more functionality and feature to the long mill in general, but also be new technologies that people could use up for any type of machine. The other like big challenge that oh, hello.
That's my son.
The other kind of like hurdles that we're looking at is scaling. So I'm not sure if you're familiar, but since last June, we went from we basically doubled our sales over like 2 or 3 months, month over month, and that was like a big process in terms of scaling. We're kind of at the plateau where we're selling a pretty consistent number of machines per month, and we have more control over what our demand looks like by changing our marketing and communication with the public, as well as now we're working with more creators to have more content out there. So we've kind of matured in terms of like the manufacturing scaling process, and now we're working on efficiency. How do we pack machines better? How do we redesign components to perform better, but also be easier to manufacture? Quality control is also a really important part. A lot of the components that we would buy off the shelf, we're starting to remanufacture ourselves, either making small tweaks or making them at higher tolerances than industry standard, because it gives us it ensures that the quality of the machines are going to stay more consistent batch to batch. For example, the router mounts are all going to be custom, or we actually have a batch on its way. All the couplers have been custom for the last batch or two, I think 1 or 2 batches, and that's eliminated a huge amount of quality control problems. Well, we never really had a huge amount, but we're talking about like single-digit percentages, or sub-tenths of percentages. But obviously, at scale, that's a lot of couplers, right?
Mm-hmm.
So yeah, those are kind of things in general. The other thing I guess we can mention is that when we first started the company, we had to build machines at a small scale. We had to make designs so that they would be affordable, even if we're making 100 units. Now we're making 1,000 units. So we're starting and then the next batch will probably be more than 1,000 units, either 1,500 to 2,000 units in a batch. We make machines in batches. We're in batch 5. So in batch 6, because our volumes are so much larger, we have the opportunity to start to redesign components to not just use off-the-shelf parts, but start to redesign components specific for CNC applications. So that could, I don't have anything that I can share at this point, but right, like as you might be aware, a lot of the components kind of come from CNC hardware. Some of it comes from other pre-designed CNC. Sorry, some of it comes from 3D printer hardware. Some of it comes from previous CNC designs. Now we have the opportunity to perfect those designs to work the best with a long mill, and so that's kind of the next step for what we're doing. So it's kind of fun because we started off as the underdogs, but now at the scale we have the opportunity to be the pioneers to design new things, and we have the scale to make that possible and affordable for people. So that's going to be what you're going to be seeing in the next 365 days.
It's pretty exciting. Your client base. So you guys are sitting there and you're looking at where these are being purchased from. I mean, like, what's the scale? Like, like as far as are like obviously I'm thinking North America would be a big market, but are you finding that you're getting a lot of orders from other parts of the world?
Yeah, so I would say our split is about 50% Canadian and 50% American. And then we have a small number, maybe about 5 to 10% that's outside of that demographic. Europe is a pretty, like, I would say Europe is probably out of that 5 to 10%, Europe is like our biggest segment. And then we have Japan as like a pretty big segment. So, and Australia. Yeah, so the thing about CNC machines though is that they're big and heavy, so they do cost a lot of money to ship to overseas. Although we found that people, seeing as how affordable the machine is and how expensive the next like competitor is, it's still cheaper to buy a long mill and pay the premium on the shipping. So
Totally agree.
That is what it is.
Totally agree.
Yeah. We've so far have sent machines to just over 40 countries. So yeah, like I think if you put all of the machines on a map, you have a pretty good chance that you're going to find another person with one of our machines like within a 3-hour driving distance, except like in some remote parts of like Arizona and stuff like that. So I don't know, random fact.
Well, it's exciting. I don't want to keep you any longer. You've been very gracious with your time today, Andy. But again, thank you very much. Thanks for the time. Thank you to you and all your staff and Chris over your shoulder there for all the patience that you have with us and the kindness you have in showing us the arc, if you will, and everything else in the shop. I look forward to talking to you again really soon. So thank you very much for your time, and I look forward to seeing you guys down the road.
Yeah, thanks for having me on the show, and yeah, we'll stay in touch, and hope everyone enjoys making stuff on their machines.
Thank you.
All right, bye-bye.
Bye.